Very good morning, friends. Am I audible? Am I audible? No, right. See, yesterday's class, what we have done, we just started with this theory called as Plate Tectonic Theory. Somewhere I was talking about the significance of this theory. At least for the examination, I said the probability of question being asked in this theory is what? Very high. Okay. Now, what exactly is the objective of this theory? Somewhere I said this Plate Tectonic Theory somewhere analyzes the locational aspect of all endogenic forces. And that locational aspect also we know. Whenever I just talk about endogenic forces, my dear friends, where exactly this endogenic force normally gets confined to, if you ask me, it is along plate boundaries. So plate tectonic theory will somewhere help us in analyzing these different types of plate boundaries. And I also told you that what exactly is the basis on which this theory was constructed. Somewhere we said this lithosphere is floating over asthenosphere and eventually it is drifting under the influence of convective magma. Having said this, while discussing about this plate tectonic theory, it is all about discussing about different types of plate boundaries, right? So accordingly, we said there are three different types of plate boundaries. What are they? One, you call them as what? Convergent. Two, you call them as what? Divergent. And three, you call them as what? Transform. Approximately, we have an idea that what exactly is convergent, divergent, and transform. Okay, see, actually speaking, the boundaries are only three types. But what we have done, just for our understanding, say for example, for a better understanding what we have done, one convergent boundary itself further we have subclassified into three further categories for the simple reason. Somewhere I understand that crust itself is of two types. Two types of crust we talked about. What are the two types of crust? One we were calling it as what? Oceanic crust, and two you call them as what? Continental crust. Because see, I understand. Whenever I talk about plate, what exactly is a plate? Plate is nothing but what? Fragmented lithosphere. Okay. See, lithosphere and crust, they are correlated. For example, the kind of the crust is going to make the kind of or the type of lithosphere. If the crust is lithosphere, obviously speaking, when talk about, say, for example, the crust is oceanic crust, then obviously the lithosphere will also be what? Say, for example, oceanic lithosphere. That's the reason. Sometimes when we refer, say, for example, some of the diagrams, you may also find this word oceanic lithosphere is given. Some of the images, what we have taken for our, say, for example, discussion, you find a word called as oceanic lithosphere. See, I know oceanic crust. Why exactly? Sometimes it is written as oceanic lithosphere for the simple reason type of crust will be making what type of lithosphere. Okay. Then I do find a word called as continental lithosphere. But to be very precise, we don't prefer this word lithosphere. Instead of lithosphere, we use this word called as what? Crustables. Okay. But you have the liberty of using it interchangeably, though technically they are different. Okay. So having said this, when I talk about, say, for example, this crust itself being two types. So as I said, what we have done, this convergent boundary, again, we have divided into three different types. Okay. Similarly, when I talk about divergent boundary, my dear friends, again, we should have divided as three different types. But somewhere I said there is an exception. We do not have anything called as what? Ocean, continent, divergence. For that, we justified. Whenever I talk about divergence, only one type of rock will get divided and it will be going for what? Divergence. If this divergence is taking place in ocean floor, that divergence becomes an example of what? Ocean divergence. If this divergence takes place in the continental crust, then that becomes an example of what? Continent divergence. Again, I am reiterating this fact that I do not have anything called as ocean and continent divergence taking place. Okay. And transform boundary, we have not subdivided further. Okay. For the simple reason, we said transform boundary itself is a very small boundary. Subdividing, if you want to subdivide, you can subdivide, but it doesn't make any meaning. That's the reason I'm not going for subdivision, right? So somewhere I said these three boundaries, we have made it as 6 boundaries, and we started discussing about each and every boundary in detail, right? Somewhere I also said that ocean continent convergence is the one which will take more time for, say, for example, analysis, because while discussing about this ocean continent convergence, we'll understand the process called as subduction. We came across a feature called as trench. We have come across again a process called as volcanic activity and the features resulted by it. Okay. So many features will be somewhere taking for our discussion. Okay. Right. Now, one by one we started with mediums, right? And when I talk about this ocean continent convergence, where ocean and land is going for convergence. I have given you a specific example, but the general example is very, very important. What is the general example we have taken? It is circum-Pacific belt, all sides of Pacific Ocean, periphery of the Pacific Ocean. Somewhere we said it is known for what? Convergent boundary, all sides of Pacific Ocean. Why? Because if I just talk about this Pacific Ocean, one side I have North American plate and Pacific plate going for what? Convergence. Here and there I have a small exception, but otherwise largely they go for what? Convergence. Nazca plate and South American plate again goes for what? Convergence. Eurasian plate and again Pacific plate goes for what? Convergence. Eurasian plate and Philippine plate goes for what? Convergence. Okay. If that is the case, somewhere I understand that all sides of Pacific Ocean, what we largely have is what? A convergent, a destructive boundary as such. Okay. The circum-Pacific belt as a zone is very, very important. And separately also we talked about this circum-Pacific belt towards the end of the last class, right? We talked about this Pacific ring of fire and some very important facts we have. Now what happens? Whenever two different types of crust goes for a convergence, where one crust is heavy and another crust is light, whichever crust is heavy, heavier crust will be going for what? Subduction. And wherever I can see that subduction taking place, right? That visible zone of subduction is what you call them as what? Trench. You call it as a trench, right? See, somewhere I understand wherever subduction takes place, not okay. We have defined the trench also. We said trench is a linear zone of depression in the ocean floor, and every trench you take it, that will be having a depth of more than 6,000 meters below mean sea level, right? Whenever I say below mean sea level, I use this symbol called as what? Inverted triangle. Okay, right. And so the very important trenches of the world also we have taken. So many trenches we have taken it, and somewhere I also reiterate the fact that trenches generally takes the name of the coastline. Okay. The only challenge I have to remember where exactly this coastline is located. Okay, right. Then we did not stop there. Somewhere we said whenever the subduction is taking place, the subduction or oceanic crust which goes for subduction, eventually when it enters asthenosphere, it also goes for what? Destruction. Am I right? Okay. Whatever it is the case, it goes for a destruction. And somewhere I understand destruction is a continuous process. The magma load will increase. If the magma load is increasing, right? You can say by, right? Okay. Okay, whatever it is the case, somewhere I'm just telling you, right? When the magma load increases, what happens? This magma will try to come to the surface of the earth. And that, say, for example, activity or that event of magma rising towards the surface of the earth, we call them as what? Volcanic activity. Maybe let me zoom in. So when this magma starts rising towards the surface, we call them as what? Volcanic activity. I also told you that volcanic activity is more like a vent mechanism. It is more like a pressure releasing mechanism. So whenever the pressure of asthenosphere increases, if it eventually gets released, you call them as what? Volcanic activity. Right? And I know the fact that this rising magma can result in number of features. One feature can be what? Volcano. Volcano is more like what? Mountain. If you remember, we talked about 4 types of mountains. Right? One is fold, 2 is block, and third type of mountain is what? Volcanic mountain. So somewhere this rising magma can result in what? Creation of a volcano, which is nothing but what? A mountain. On the other side, the rising magma can also result, say for example, if at all if it is rising along the ocean floor, it can also result what? Volcanic island. Same volcano, but if at all if it is there in the middle of the ocean or somewhere in the oceanic region, I can call them as what? So volcanic activity can create features like volcano. It can also create features like island. Okay, right. Now, what is the default region we have taken for this example is circum-Pacific belt. And I told you, circum-Pacific belt, because of this reason, is dominated with the presence of, because of the subduction I said, circum-Pacific belt is dominated with the presence of large number of volcanoes. Large number of volcanoes, right? And that's the reason this region is very popularly, you call them as what? Pacific ring of fire. Having said this, why exactly you call this as ring of fire? We have justified, and somewhere we said it is not only volcanoes what we have in this region. Apart from that, we said this region is also known for what? Large number of earthquakes. This region is known for presence of trenches, and it is also prone to what? Tsunami. Okay. Now, while writing, we said approximately this region has somewhere around 450 active and dormant volcanoes. In this list, what I have not included is what? Extinct volcanoes I have not included. Okay. Only these two types of volcanoes I have listed. And somewhere the statistics also says more than 80% of world's volcanic populations are located where? Along the circumpolar. Okay, so today what we have to do, some of these volcanoes we have to take it. Few examples, right? Every continent, one or two examples if we take it, that should be more than enough, right? We'll take some examples in North America, South America, right? And say for example, this Asian site. If possible, we'll also access this Indian information. Okay. Just come to map of North America. You're there in North America. You're there along this Pacific coastline, one by one. Directly, let me not take you to this location. Can you find this? Okay. Do you know what exactly is this 49th parallel? Have you heard about this 49th parallel? What is this 49th parallel? See, what do you mean by parallel? Geography, what do you mean by parallel? Use this term called as parallel. What do you mean by parallel? Latitude. Parallel is the other name for what? Latitude. Why latitudes are called as parallel already we have justified. Okay. See, some of the very important parallels you come across, right? Latitudes, right? All the names what I'm just giving you. It's a very popular latitude. 49th parallel, 38th parallel, right? At least here in this map, what you find is what? 49th parallel. What is 49th parallel? Can you find a international boundary between USA and Canada? Almost this boundary is a straight line. Towards the western side, it is a straight line. Towards the eastern side, it is not a straight line. Towards the eastern side, you have plenty of lakes there, Great Lakes. Okay. Put yourself in the western side. Western side is more like a straight line. This line is what you call them as what? 49th parallel. Now you're there along the west coast, right? USA and Canada border, you're there along the west coast. Within USA, can you find this state called as Washington? Washington? Political map to be very precise. Political map. See, this is the western, northwestern part of US. State is called as Washington. Washington state is different. Washington DC is different. Okay. DC is in the east coast. That is the capital, District of Columbia, right? Now here, if you're there in Washington, can you find this place called as Seattle? Seattle? No. Microsoft, right? Now what do? You just take this Seattle and put it in physical. Don't ask me how to take it. Okay, right. Somewhere, I just want you to locate approximately in physical. Okay. So once you locate it very near to it, can you find a volcano? Any volcano is represented as a peak, right? Upright triangle. Can you find this volcano called as Mount Rainier? Mount Rainier. See, even if you're not able to find the Mount Rainier, I'm not worried about, because now I know what is 49th parallel. Now I know where exactly Washington state is located. Okay. So these are the value additions. Okay. So once you identify Mount Rainier is a volcano. And slightly south of Mount Rainier, can you find one more volcano called as St. Helens? Slightly south of St. Helens. Okay. So two volcanoes we have identified. See, plenty of volcanoes are there, but somewhere I feel that per continent, two names if you're adding it, that should be more than enough, right? Now turn few pages, come to map of South America, page number 88. See, these maps, these names are very important. The names what we are going to take now, South American example, they are very, very important. For example, can you find this country called as Ecuador? Country is called as Ecuador. What exactly it means? Why exactly this country is called as Ecuador? Because I understand this country is located somewhere. Equator is cutting across this country. That's the reason this country is named as Ecuador itself, right? Now, if you're there in Ecuador, physical map, how to find Ecuador? Very simple. First, find equator first. Okay. Now, Somewhere if you're there in this physical map, you find some of the very prominent volcanoes, right? You find some of the peaks. You yourself can take the names and tell them. You find the mountains like Mount Cotopaxi, and very near to Mount Cotopaxi, you find volcanoes like Mount Chimborazo. Chimborazo, okay. Whatever it is, I guess, right? Chimborazo. Mount Cotopaxi and Chimborazo. Both are volcanoes, very prominent names. Right? So 2 per continent we have taken it. And finally, now you come to map of Asia. Map of Asia. 66. Okay. Now, if you're there in map of Asia, you put yourself on the eastern side, you're there in the Russian side, Russia. In Russia, you have a peninsula. This peninsula, you call them as what? Kamchatka Peninsula. And you find this sea called the Sea of Okhotsk. You find Kuril Islands, right? Just north of Kuril Islands, you have one peninsula. This peninsula, you call them as what? Kamchatka Peninsula. Kamchatka Peninsula is not volcano, right? If you're there in this peninsula, you know what is peninsula, right? What is peninsula? A region which is 3 sides surrounded by water, you call them as what? Peninsula. Okay. Now, if you're there in peninsula, Kamchatka Peninsula, you find one volcano there. Only one volcano is given. It is given as a peak. You call it as what? But don't worry about the Russian names. I would have told you that how to identify the Russian names in examination, right? Okay. Right. So don't worry about the Russian names. But this volcano is some volcano starts with alphabet K. Am I right? That should be more than enough, right? This volcano, you call them as what? Kluchevskaya. It's called as Kluchevskaya, but not so important. Try avoiding taking the names because anyway you're not going to remember it. Okay, right. Now, what you do, what is very, very important, just south of this Kamchatka Peninsula, you are somewhere you'll be entering Japan. Once you enter Japan, this name is very, very popular. Very popular. This most popular name, right? Volcano in Japan, you call them as what? Mount Fuji. Or sometimes it is actually entire. The complete name you call them as what? Mount Fuji. You call them as what? Mount Fuji Shan. Or sometimes it is also called as Mount Fuji Yama. Right? The complete name is Fuji Shan. All are same. Mount Fuji, Fuji Shan, Fuji Yama. But in map of Asia, you'll be finding only this word Fuji is given. Fuji Shan is not given. Reason is very simple. We do not have space to write it. Okay. So once you go to the regional map, you will be finding the entire thing. Shan means mountain, right? Okay. Right, my dear friends. Few continents, few names we have taken. See here, all the volcanoes what I have just given you, they are located along the continental sides. Okay. They are located along the land. That's the reason you call it as volcano itself. Okay. And one more thing, very carefully if you have to identify, Mount Rainier and St. Helens are located over and above which mountain? Rocky Mountain. Very good. What type of mountain is Rocky Mountain? Right? Young Fold Mountain. Similarly, Cotopaxi and Chimborazo, they are located over and above which mountain? Andes Mountain. What type of mountain is Andes Mountains? Again, it is what? Young Fold Mountain. So, most of the volcanoes you'll be finding they are located along these stretches of what? Young Fold Mountains. The place where I have Young Fold Mountain will also be the same place where I'll be having what? Volcanoes. We do have exceptions, but otherwise, this volcanoes and fold mountains are very closely associated because both coexist in the same location. Okay. See, the only difference I told you, we're talking about the locational aspect, right? When I talk about any convergence that is taking place on the land side, I'll be having what? Fold mountain. That is the same place where I can also have the presence of what? Volcano. They coexist together. Okay. Right. So I'll also give you volcano existing as a form of an island. Plenty of global examples are there, but I'll go for Indian example. I come to page number 29. or select this Andaman and Nicobar Islands. Andaman and Nicobar Islands. You have a separate map for Andaman and Nicobar Islands. Okay. So once you are there in this map, once you are there in this Andaman and Nicobar Islands, we do have islands, right? We do have volcanic islands. India has volcanoes, and where exactly we have volcanoes in India? Where? Okay, Barren Island. And one small clarification. Wikipedia information says that Haryana also you have volcano, Gujarat also you have volcano. List of volcanoes. Haryana is given, Gujarat is given, Doshi Hills, Tosham Mountains, Dinodar Hills, plenty of names they have given it. But one small clarification. What is the clarification? If I just talk about volcanoes in India, where exactly we have volcano in India? We do have volcano in Andaman. Here. We have at least 2 volcanoes in Andaman. One you call them as what? Barren Island, and 2 you call them as what? Narkund. Right? See, for example, here there is one volcano called as Baratang. Baratang is a mud volcano. Actually speaking, it is not a volcano in its right nomenclature as such. Right? But somewhere you have a classification called as mud volcano. Baratang is given. So to be very precise, even Baratang cannot be classified as actual volcanoes. Okay. Then very surprisingly, they have given the name of Deccan Plateau. Actually, it should not be Deccan Plateau. This should have been Deccan Trap. Right? Deccan Trap is also not a volcano. Deccan Trap is a volcanic feature. What is Deccan Trap? Deccan Trap is what? A lava plateau. This is a lava plateau. Any feature which is formed out of solidification of magma or lava, you call them as what? Volcanic features. Okay. It should not be Deccan Plateau. It should have been what? Deccan Trap instead. Okay. And all these mountains, Dinodar Hills, Toshi Hills, Tosham Mountains, right? All these volcanoes, they are not the volcanoes which is formed now. For example, all these volcanoes, Dinodar Hills, Doshi Hills, and Tosham Hills, all you take it, they are located along the stretch of what? Aravali Mountains, my dear friends. What kind of mountain is Aravali? Old fold mountain. Am I right? When Aravali would have formed, that time these volcanoes would have existed, right? Now only say, for example, the remnants of these volcanoes are there. I'll show you the image also. See, somewhere, if I'm just taking an aerial image, it appears like more like the remnants of a volcanic feature, but just to tell you, this itself is not a volcano. Okay. So what is the clarification I just want to bring it here? It's very simple. When I talk about the list of volcanoes, what is given in Wikipedia, actually speaking, there are only 2 volcanoes. All these are volcanic features I can take it. They've also given the Loktak Lake. I do not know for what reason they have given this Loktak Lake. Okay. Okay. Whatever is the case, right? To be very, very precise, all other names can be volcanic feature, but there are only 2 volcanoes in India. One is Barren Island and 2 is Narkund. Okay. Now you are there in page number 24. Sorry, 29. Sorry, same page. Andaman and Nicobar Islands. Put yourself as north as possible. You're there in the northernmost limit of this region, right? Once you reach the northernmost part of this Andaman, right, then what you do, slightly you put yourself towards the eastern side. You find one isolated island, north top of this page, right? Right at the top of this page. Okay. Once reaching the northernmost point, you're there in North Andaman, right? After reaching North Andaman, slightly put yourself to the eastern side. There can you find one isolated island. This isolated island, you call them as what? Narkund. Okay. One small clarification. In your atlas, this Narkundam is given as what? Extinct volcano. But actually speaking, 2020, they have reclassified this volcano as what? Dormant volcano. It is not extinct. See, it is not that one extinct volcano has become dormant. Earlier, our classification was wrong. Now we are rectified it. We have rectified. Now in your books itself, atlas itself, we can mark it that it is dormant, not extinct. Okay. Now one Narkundam we have just seen. Then what you do, my dear friends? The same longitude, Narkundam, the same longitude, slightly descend south, right? Slightly you descend south, what you find is what? Barren volcano. You find barren volcano, right? Or barren island, right? What you're seeing is exact picture of barren island. And within bracket it is given as what? In your atlas it is given as what? Volcano. These are the only two volcanoes what we have, right? Volcanoes existing in form of what? Islands. Okay, right. Now, all examples we have taken, right? We talked about volcanic activity, even the examples of volcano also we have taken, right? Now, what are the features and process we have taken it? For example, right? We talked about a feature called as fold mountain. Then we talked about the feature called as what? Trench. What was the process that facilitated the formation of a trench? The process called as what? Subduction. Okay. Then we talked about features like volcano. Then we talked about features like volcanic islands. And all these features are facilitated by the process called as what? Volcanic activity. Volcanic activity is nothing but what? A process. Okay. So plenty of features we have taken. See, fold mountain is also resulted by a process. What exactly is the process that facilitates the formation of fold mountain? You call them as what? Fold orogenesis, right? Name I am not giving it. It's not complicated. Okay. So features also we have taken it, process also. So one more process I'll add the process of what? Earthquake. Okay, because page number 119 and 118, whichever page, 118 I believe, right? You have this natural hazards map. What exactly this map? This map is nothing but what? Plate tectonic map. This map shows the plate boundary, right? Now the question is, why exactly this map should be called as natural hazards map? Okay, what are the different hazards? It's, say for example, somewhere it shows. It shows you the locational aspect of what? Volcanic activity. It shows the locational aspect of what? Earthquake. It shows the locational aspect of what? Tsunamis. Right. One side I understand all these are what? Endogenic process. Another side I also understand they are natural disaster. That's the reason sometimes you call this map as what? Natural hazards. Okay, now comes the question and concept called as earthquake, right? Now, few things I have to understand with respect to earthquake, my dear friends, right? What do you mean by earthquake? Name itself gives you an idea. Earthquake, right? What do you mean by earthquake? Shaking of Earth's surface, you call them as what? Earth. See, quack means what? Maybe here quack means shaking, right? Quacking of a sea, nothing wrong. What is earthquake? If you ask me, I would say quacking of earth is called as earthquake. I'm not wrong. Correct. Quacking means what? Shaking. Slightly, let me refine it. Shaking of earth's surface, you call them as what? Earth. Then comes one more question. Why exactly this, say for example, shaking is happening? Because somewhere some energy is released. This energy, when it travels via different layers of the rock, that shaking amplitude will be resultant. Am I right? So, earthquake is all about shaking of Earth's surface. I'm not denying the fact, but why exactly it is shaking? What is the causative factor? Because somewhere, all of a sudden, energy would have been released what? Suddenly. So, that's the reason the sudden release of energy, we call them as what? Earthquake. Okay, right. Now, say for example, why exactly energy is released suddenly, I asked. Okay, somewhere, let me understand. For example, assume that I have a rock, my dear friend. Some rocks are there. Okay, whatever is the type of rock. Okay. You induce some stress in this rock strata. See, for example, I told you, any plate boundary you take it, some kind of stress is always there. Only the type of stress is different. When I talk about, say, for example, convergent boundary, what kind of stress is there? Compressional stress. Divergent boundary, what kind of stress is there? Tensile stress or tensional stress, you call them as, right? Transform boundary, what kind of stress is there? Shearing stress. So, what is very common is what? Stress. Am I right? So, you're not alone, right? Earthquake is there with you, right? So, what I'm just trying to say, somewhere, for example, universally, any plate boundary I take it, I'll be having some kind of stress that is applied. Okay. So, what happens? Whenever the stress is applied on a rock strata, this applied stress will be stored in form of some energy within this rock. Maybe I'll put it this way, right? I'll take an example of a balloon, right? Say, for example, imagine that I'm going to inflate a balloon, right? I'm just buying a balloon, right? For my friend's birthday, somewhere I'm just inflating this balloon. So, okay. Only thing is that instead of rock, I'm taking this balloon as for an experiment, right? So what I'm just doing now, I'm just blowing the balloon, I'm just inflating the balloon. Once I start blowing the balloon, what will happen to the balloon? This balloon will become bigger. Alright. Something like this. My act of inflating the balloon is more like I'm inducing stress in this balloon. Okay. So whenever the stress is induced, what will happen? The stress will be resulting in a strain. Okay. So what is strain? If you ask me, what exactly is a strain? Whenever there is a change in the shape or volume, or sometimes both, right, of a rock, you call them as what? Strain, right? Whenever I induce a stress, if it is permanently, say for example, if the shape and volume are changing, you call them as what? Strain. Something like that. See, balloon is elastic, okay, but still, what I'm just trying to say, my induced stress will change the shape of this balloon, okay, or at least the volume of the balloon time being. Okay. Now, what I'm just doing, again, I'm inflating this balloon, again, I'm blowing this balloon. What will happen to the balloon? Balloon will still become bigger. Further, I'm inflating the balloon. What will happen? Again, it will become bigger, right? Now, assume that this balloon is becoming, right, somewhere reaching a threshold limit. Okay, somewhere it is reaching a threshold limit. What is the threshold limit unit, right? The maximum capacity what this balloon can withstand, you call them as what? Threshold. Okay. Now, still you want to blow this balloon. You are buying a balloon for 5 rupees and you want to blow it for 10 rupees. Okay. What will happen to this balloon? Balloon will burst. Now comes the question. If the balloon burst opens, what will happen? It is not, say for example, only the last set of energy that will be released. All that energy which is stored inside the balloon from the beginning, which gets accumulated, all this accumulated energy will suddenly get released at once. Am I right? Now what you do, instead of balloon, I'll replace it with a rock. Okay. You induce some stress in this rock. Induced stress is resulting in strain. That is one aspect. But somewhere I understand the stress is actually stored inside the rock in form of some energy. Again, the stress is induced. Again, the energy is accumulating. Right? Slowly, steadily, the energy is getting accumulated in the rock strata. Now it is reaching a threshold limit, maximum capacity. Right? Now, if further stress induces, what happens? If at all further stress is induced, what will happen to the rock? The rock will break. When the rock breaks open, all that accumulated energy will get released suddenly. That sudden release of energy is what you call them as what? Earthquake. Okay. So somewhere, can you write a small definition about this? Sudden release of energy. Sudden release of energy. Or you can add one word. Sudden release of accumulated energy. Sudden release of accumulated energy from a deformed rock. From a deformed rock. Which induces, from a deformed rock, which induces the shaking of Earth's surface, which induces the shaking of Earth's surface, is called as earthquake. It's called as earthquake. I repeat again, I said, sudden release of accumulated energy from a deformed rock, which induces the shaking of Earth's surface, is called as earthquake. So somewhere, earthquake is all about shaking of Earth's surface. I'm not denying the fact. But why exactly this Earth's surface is shaking? It is all because of what? Sudden release of energy. So whenever you experience an earthquake, somewhere I can conclude that somewhere some rock was subjected to what? Breakage. Okay. Only if rock breaks, I'll be having this release of energy taking place. Right. Now, what is an earthquake? I understand. Now you tell me my difference. Location. Where all I can have an earthquake. Where all I can have an earthquake. Location. Plate boundaries. Okay. Comes one question. Somewhere you are preparing for civil service. You want to prepare for civil service very peacefully, right? You don't want any earthquake, right? So you are searching for a place which is completely free from earthquake. So which is that part in India you will be preparing for your examination? Where exactly eventually you will get settled? Okay, if not in India, which part of the world you will go and settle eventually, which is completely free from earthquake? Tell me one place in this earth which is free from earthquake. One place. Right. What you anticipate is exactly correct. There is not even a single place in this earth which is relatively or completely free from what? Earthquake. Wherever you are there in this earth, somewhere the probability of having an earthquake is always what is there, right? But what will change from place to place and time to time is the frequency, magnitude, and intensity. Somewhere if you feel that, okay, I do not want an earthquake to happen, right? Somewhere I am phobic to earthquake, then Earth is not the place for you. Maybe you can go to moon, right? Just you missed Chandrayaan, right? But today Aditya is going, am I right? Somewhere try Aditya one. Okay. Okay. Whatever it is the case, what I'm just trying to say, see, moon, certainly speaking, earthquake is not there. Moonquake can be there. Am I right? Okay, right. Now coming back here, right? I'm just talking about earthquake. One logic, we have an idea that anywhere you are there in this earth, somewhere you will be having an earthquake. But repeatedly, as I said, what may change is frequency, magnitude, and the intensity. Okay. Kindly come to page number, I think 60 of your atlas. Natural hazards map of India, where you will be finding the different regions in India is divided into different seismic zones. Right? You find that, say, for example, the entire India is divided into, at least in your atlas, it is divided into how many zones? It is not 4. In your atlas, it is given as what? 5. Right? Somewhere, you are there in your, say, for example, atlas, top right corner of this page. You find these 5 zones, right? What are the 5 zones? You call them as what? Very high damage risk zone, high damage risk zone, moderate damage risk zone, low damage risk zone, and very low damage risk zone. Okay. A small clarification. NDMA's classification. NDMA has not classified 5 zones. NDMA's classification is only what? 4 zones. They have zone 5, they have zone 4, they have zone 3, they have zone 2. Actually speaking, there is no zone 1 classification in NDMA. Okay. So NDMA, National Disaster Management Authority, they have divided this. Say, for example, seismic zones of India only into what? 4 categories. Okay. Now, how you can say, for example, rewrite it, what is given as very high damage risk zone is nothing but what? Zone 5. There itself, you can write it as zone 5. Roman letter 5, you can write it as. According to NDMA, that is nothing but what? Zone 5. See, though it is not clear, I'm just taking the image from the primary source itself, right? What you have is only 4 zones given. Zone 5, zone 4, zone 3, and zone 2 is given, right? What is zone 5? Very high damage risk zone. In your atlas itself, you find something called as what? Very high damage risk. Zone 4, in your atlas, what is given as high damage risk zone, you write it as what? Zone 4. In your atlas, you'll be finding this word called as what? High damage risk. Okay. Then what is given in your atlas as moderate damage risk zone, that you can write it as what? Zone 3. Okay. Then what is remaining 2? In your atlas, what is given as low and very low, both put together and marked it as zone. So 5, we are just making into what? 4. Only last 2 category, what is given as low damage risk zone and very low damage risk zone, put together we are calling it as what? Zone 2 according to NDMA's classification. Now let us come to the main aspect of our discussion. Okay. Entire India is divided into 4 zones, NDMA's classification. Your atlas, it is written as 5 zones. Now you tell me, what do you mean by very low damage risk zone? What do you mean by very low damage risk zone? Can I conclude that this region, earthquake will not happen? Can I take it this way? This region is completely free from earthquake? No. It means somewhere they are indirectly saying that earthquake possibility is what? Very less. Probability of having an earthquake is what? Very less. Even if you have an earthquake, the size of an earthquake may not be so great. That is the meaning. Right? You have a proverb, right? Barking dog seldom bites. Right? What do you mean by seldom? What do you mean by seldom? Some of the translation mistake, right? Some of, say, for example, few languages, they have translated and said that barking dogs never bite. Right? You also experiment it. You put your hand inside the mouth of the dog and see whether it bites or not. Okay. Seldom means very rarely. Okay. It is more like seldom. Very rarely I can. Okay. So when I talk about this low probability, somewhere it says that yes, you may have an earthquake, right? But the frequency will be less. Of course, the size of an earthquake will be less. I'll give you some of the examples, right? You're there in eastern Maharashtra. Tell me, eastern Maharashtra falls under which category? Eastern Maharashtra. Just look for your map, your own map. Look for eastern Maharashtra. Eastern Maharashtra falls under which category? Can I call it a zone 2? Zone 2 is nothing but what? Low damage risk. Okay. So somewhere I understand this region should be free from what? Or at least relatively free from earthquake. But in 1993, my dear friends, 1993, we had one devastating earthquake here. Right? Have you heard about this earthquake called as Latur earthquake? Latur earthquake. It's considered as one of the most devastating earthquake in the peninsular India. Right? More than 10,000 means lives we have lost in this earthquake. But what is the irony of the story? Right? This region called as Latur is actually located in which zone? Zone 2. What you perceive to be a safer zone of earthquake, right? Somewhere we have experienced what? One of the devastating earthquake. But to be very precise, that is not a natural earthquake. This earthquake was man-made earthquake. We call them as what? Anthropogenic earthquakes. Okay, now, fine. Earthquake zones in India, we have just taken it. Now, what is important here? Let me concentrate on the zone 5 regions of India, right? All the zone 5 regions of India, if I just take it, right? 7 regions are there, right? Totally, there are 7 regions of it. Can you identify the 7 regions? Somewhere possible, if you can write it also. What are the 7 regions? Number 1, always follow some order. Look for the zone 5. Number 1, start from Gujarat. You're there in Run of Kutch region. Remember it? So what do? You write a heading called as zone 5 in India. Very, very important. Zone 5 in India. The regions which is more prone to earthquakes, highly prone to earthquakes. Number 1 is Kutch Peninsula. Kutch Peninsula. See this map, what you're seeing, this map correction was made in the year 2002. Because before 2002, we never know that Gujarat was prone to what? Earthquake. Right. 2001, January 26th, we had one devastating earthquake in Gujarat. I heard about this earthquake called as Bhuj earthquake, right? So only after having this Bhuj earthquake, we have marked this seismic. See, some of the countries like Japan versus country like India, one small difference is there when it comes to earthquake zonations. Japan will be, say, for example, doing their artificial seismic waves they'll be producing, right? They'll be intensively studying the different rocks, right? Underlying rocks, and they'll be declaring that this region is prone to earthquake. It means they'll be identifying the zone and they'll be waiting for the earthquake to come. Am I right? India slightly the, say, for example, practice is different. First, you will wait for an earthquake to come, right? Then you'll be identifying this zones. Okay. Sarcastic way of saying, but this is the harsh reality. Okay. Why? Because 2001 we had this Bhuj earthquake. 2002 we have included in the map. Okay. That should not be the right way of doing it. Okay. Whatever it is the case. Number 1, Kutch Peninsula. The second example, Kashmir Valley. Kashmir Valley. In and around Srinagar. Number 3, Himachal Pradesh. Himachal Pradesh. And these regions are highly prone to earthquake. Himachal Pradesh. Number 4, Eastern Uttarakhand, very near to Mussoorie, right? After doing so much of hard work, you are going to a place which is prone to earthquake. Kindly ensure that your hard work is not wasted. Okay. You're there in the Eastern Uttarakhand. Number 4. Number 5, Northern Bihar. Northern Bihar. Number 6, northeastern states except Sikkim. Sikkim falls under zone 4 category. That's the reason I'm just putting it as northeastern state except Sikkim. 6 regions I have identified. You tell me what is 7th region. Andaman and Nicobar Island. 7 is Andaman and Nicobar Island. Now, my dear friends, 7 regions we have identified. Okay, I'll just keep Gujarat out. Okay, rest of the 6 regions, if I just take it, what is so common among them? All these regions? What is so common among them? Sorry, very good. They are nothing but what? Stretches of what? Fold mountains. To be very precise, they are the stretches of what? Young fold mountains. Right. See, one side they are young fold mountain. I am not denying the fact, but they are nothing but what? Active, right? They are active tectonic plate boundaries. So wherever I have an active plate boundary, there all I understand. There's a chance that I'll be having, right? This region will be highly susceptible to what? Earthquake as such. And let me also tell you, young fold mountains are those regions in the world which is highly prone to what? Earthquake. Okay. See, again, we have taken the example of what? Circum-Pacific belt. Somewhere we said 90% of world's large earthquakes are confined where? Circum-Pacific belt, because I should understand that Circum-Pacific belt throughout the stretch, I also have the presence of what? Young fold mountains, right? Young fold mountains like Rocky Mountains, young fold mountains like Andes, right? See, for example, 1960s earthquake of Chile, Chilean earthquake. Again, I understand Chile is located, say for example, I put it right, Andes is located in this country called as what? Chile, right? And this earthquake, what we had in 1960s in Chile, is considered to be the largest earthquake what humans have recorded in their history, right? Again, what is Andes? Andes is a fold mountain. So any fold mountain you take it, young fold mountain you take it, they will be prone to what? Earthquake. Okay, right. So what we have discussed now, what is an earthquake we have discussed, right? What are the regions in India which is more prone to earthquake we have discussed, and that 7 regions what I have given as zone 5, they are very, very important. And we also discussed about the commonality. Barring the exception of Gujarat, we said the rest of it, they are located in what? Active tectonic plate. Okay. Now, my dear friends, one boundary we have completed. We'll try to consolidate all the information, right? So what we have done here, we have identified some of the features and we have also talked about some of the process. As a feature, see, for example, this is a place where ocean and continent goes for what? Convergence, right? When ocean and continent goes for a convergence, on the continent side, what I'll be having is what? Fold mountain, right? And the ocean side, what I'll be having is what? Trench. That's the reason whenever I have this ocean and continent convergence, this fold mountain and trench will be located parallel to each other, correct? Finest example, page number 88. South American map. Map of South America. Along the west coast of South America, I have a continuous mountain stretch called as Andes. Along the, say for example, Andes, along the coastline, parallel to the coastline, I also have one. The world's longest trench, one side world's longest mountain, another side parallel to it, I have what? World's longest trench. But both are located what? Parallel to each other. Okay, right? So wherever convergence of ocean and continent takes place, ocean side I'll be having a trench, continent side I'll be having what? Fold. Okay. And trench is nothing but what? Zone of subduction. Subduction will lead to destruction, and destruction will be resulting in what? Volcanic activity, right? And when this magma starts rising magma on the continental side can create what? Volcano. On the ocean side can create what? Fires. And I understand, say for example, this is the same place which is also more prone to what? Earthquakes. Okay. So wherever I have a fold mountain, there I may find what? Volcanoes. And I understand that they are also susceptible to what? Earthquakes as such. This is the right, that table of consolidation. Right. All what we have discussed, somewhere I have consolidated. Where, what feature, and what process will be having it. Okay. Right. Other boundaries may not take much time. Okay. Now going to the second boundary. Second boundary I call them as what? Continent convergence. I am talking about a place where land and land is going for a convergence. Can you give me an example of it? Give me one example of continent convergence. Convergence somewhere in the middle of the land. Both side of this boundary I have continental. You go to your, say for example, this natural hazards map, then you can give me an example. Eurasian plate and Indo-Australian plate going for a convergence, right? Okay, going for a convergence. Classical example. Because that's the place where I have the formation of what? Himalayas. So Himalayas located in a place where both side I have what? Continental crust which is going for what? Convergence. One by one, if I just talk about it, right? See here, continental crust and continental crust going for a convergence. What is the default feature I'll be having? Cold mountain. Am I right? They go for a convergence, compressional stress is induced, the rock will subject it to what? Folding. Upfolded part becomes an example of what? Fold mountain. Anticline becomes an example of fold. Simple, right? Let's not even explain. Convergence, land, fold mountain. Will you have subduction taking place here? No. Because I understand both the crust are similar in use. See, one crust can override another, that is possible. But one crust subducting below another, somewhere, say for example, eventually entering asthenosphere is not ordinarily possible. If that is the case, if subduction is not taking place, see, talking about trench and all, it is ruled out. I do not have ocean, so let's not talk about trench. Okay. I do not have oceans, let's not talk about islands. Okay. Here the subduction is not going to take place. If subduction do not takes place, what will not happen is what? Destruction. If destruction is not taking place, what I may not have is volcanic activity. So, wherever I have a fold mountain which is resulted due to continent-continent convergence, this type of fold mountains, I will not have what? Volcanoes. Very, very important. Himalayas is the only region in the world or only fold mountain systems in the world which do not have volcanoes. Because it is purely continent-continent convergence. You don't have volcanoes in Himalayas. Just to slightly confuse you and just a slight deviation. Confusion is good for a greater understanding, right? If that is the case, have you heard about something called as hot springs, geysers? Not the one you find it in the morning, right? I'm just talking about what? Right, hot springs and geysers, say for example, as the name suggests, what are they if you ask me? They are warm waters. See, sometimes what you find, say for example, small ponds will be there, lakes will be there, some small streams of rivers will be there, right? And this water will be warm, right? Such streams you call them as what? Hot springs. You call them as what? Hot springs, right? Sometimes what happens, you find that this hot water or warm water will be gushing out like a fountain. With all pressure, it will be coming to the surface, right? That pressurized warm water, you call them as what? Geysers. You call it as a geysers. Approximately what you see here is more like a hot spring, right? The vapor or the steam, what exactly comes out, it tells that it is more like a hot spring, right? And talk about geyser, like a fountain, it will be gushing out. What do you find here? As I said, like a fountain, this hot water will be gushing out. This is what you call them as what? Geysers. Okay. Just somewhere showing you that how exactly this hot spring and geyser may look like. Okay. Now the question is, hot spring and geyser, what is more common between them? Both are warm waters. Okay. Both are hot waters. But what exactly is the difference? When this hot water come to the surface without pressure, you call them as what? Hot spring. If it is coming with pressure, you call them as what? Geysers. Because that's the reason. Definition itself is a pressurized hot spring is called as what? Geysers. Now the question, what can be the source of this heat? This is a warm water, you should have a source. What can be the source of this heat? You need some source for the water to get heated up. Am I right? What can be that source? Simple, rising magma. When the magma rises, see for example, if at all if this magma is rising, rise of magma, you call them as what? Volcanic activity. The magma is rising and somewhere along its path, if it comes very near to, say for example, the percolating water or the groundwater table, what happens? There can be a transfer of heat. Okay, this water will become warm and this water, when it comes to the surface, it will come as what? Warm water. And on the other hand, there is one more chance that this rising water can also come into direct contact with water, right? Percolating water and the rise of magma can come into a direct contact. And somewhere I understand the temperature of magma is what? Extremely hot. Somewhere I have just given you the melting point of rock, right? What is the melting point of rock? Anywhere between 500 to 600 degrees centigrade is the melting point of rock. Correct? So I understand, say for example, magma's temperature will always be more than what? 500 to 600 degrees centigrade. In Earth's interior, it will be furthermore higher. Okay. So what happens when water comes into contact with this magma, which is somewhere having a temperature of more than 500 to 600 degrees centigrade? What will happen to the water? Water will get superheated. Evaporation is different. Superheated, right? Superheated in the sense water will be heated beyond the boiling point. You call them as what? Superheated. Okay. Once this water is superheated, obviously I understand it will be creating plenty of steams, right? And when this water comes to the surface, it will come out what? Like a gushing water, it will be coming out, right? So that is what you call them as what? Geysers. Okay. Coming very close to magma, this water can become an example of what? Hot spring. Coming into contact with magma, it can become what? Geysers. Okay. So slight deviation, you give a small heading called as hot springs and geysers. Why I am going for a deviation, I'll tell you. Small heading. Let's not couple it with this plate tectonic theory. Somewhere, some corner, separately we'll write it as a box item. First, we'll write a definition of hot spring, right? Warm water streams ponds or riverlet, pond, lake, pond or riverlet. Small rivers are called as riverlet. Warm water streams, ponds or riverlets, right? Riverlets. Small rivers are called as what? Riverlets, right? Riverlets are called as hot springs. Whereas pressurized hot spring is called as geysers. Pressurized hot spring is called as geysers. Hot springs and geysers, pressurized hot spring is called as geysers. Further you can write, hot springs and geysers are generally confined to the places of active volcanism. So wherever you have this active volcan means volcanism taking place, right? Where the rise of magma is very, say for example, very common. That's the place where generally you find what? These hot springs and geysers. Right. Now here, why I am discussing about these hot springs and geysers, I'll tell you, my dear friends. And one more thing, there is also one kind of non-conventional energy resource you extract from these hot springs and geysers, or you harness from these hot springs and geysers. Very popularly, you call them as what? Very good. You call them as what? Geothermal energy. Okay. Now, why I have taken these hot springs and geysers and tell you, my dear friends, because when talk about Himalayas, very interestingly, Himalayas is known for what? Hot springs. Have you heard about this place called as Manikaran? Manikaran? Which state? Very good. Himachal Pradesh. Known for what? Geothermal production, right? Apart from that, this region is known for what? Hot springs. Okay. Now, why I'm just including this, Himalayas has what? Hot spring, but Himalayas do not have what? Volcano. Am I right? When we have written it, I have just very clearly, I have told you that hot springs and geysers are generally associated with the place of active volcanism. I have used this word called as generally. Okay, it means always there is an exception. Now here comes the question, right? Can I have the presence of hot spring without the presence of volcano? Is it possible? Answer is yes, because we are having it. Okay. Himalayas volcanic activity or volcanism is not there. I do not have volcano, but hot spring is there. See, what is the clarification? Geysers cannot exist without volcanic activity, but hot springs can exist without volcanic activity. That also as a sentence, if you want, you write. You write it. Geysers are always associated with volcanic activity. Whereas hot spring can exist. Hot springs can exist even without volcanic activity. Okay. So I have given you the case of Himalayas. So what is the point I have just made it? Himalayas do not have volcano, but Himalayas has what? Hot spring. Okay. So when I just talk about the features, my dear friends, what is the only feature I have in Himalayas? Sorry. What is the only feature I have along this continent-continent convergence is what? Cold mountain. And classical example of this cold mountain is what? Himalayas. See here, we have consolidated this table. Okay. Whenever this ocean and continent goes for a convergence, what are the features I'll be having? Now I am talking about what type of convergence? Continent-continent convergence. If I talk about continent-continent convergence, I will not have what? Oceanic features, ruled out, right? In this continent-continent convergence, I also said this is the region where I do not have what? Volcano. What is the only feature it is known? Cold mountain. That's it, right? And it is also known for what? Earthquake. Okay. So that's all about continent-continent convergence. Okay. Before I go into the third, say for example, type of boundary, let me also give a complete view of this hot spring and geyser. I told you what exactly is hot spring. I told you what exactly is geyser. What is the locational aspect of it? I have told you. Right. Let me also give you some of the classical examples of prominent hot springs and geysers of it. Okay. For example, my dear friends, Iceland. The entire country is known for hot springs and geysers. Iceland. Some examples, somewhere you can take it. Iceland. Iceland has a nickname. What is the nickname that Iceland has? Iceland is called as land of ice and fire. See, why this region is called as land of ice? Why Iceland is called as land of ice? What can be the reason? If you answer this question, we can go for a break. Otherwise, also we'll go for a break. Okay, great. Okay. Located where? Polar region. Almost it is there in the polar region, right? Part of this Iceland is there in the polar region, right? Extremely cold. So I call it as an ice, right? Land of ice. Fine. Why should I call it as land of fire? When talk about geomorphology, fire indicates what? Volcanic activity. It means the entire Iceland is formed out of what? Volcanism. Am I right? Rising magma, eventually reaching the surface and cooling down, resulted in the formation of what? This region, right? So fire indicates what? Volcanic activity. That's the reason it has a nickname called as what? Land of ice and fire, right? Okay, Iceland. Then of course New Zealand, right? New Zealand is one more example of place where you have this hot spring and geyser. One small clarification: be it Iceland or be it New Zealand, both are located where, if you ask me, along plate mountain. Just come to page number 118, natural hazards map. Right? Iceland and New Zealand, both I have just taken. Both are located along their respective plate mountains. But only basic difference, if you ask me, right? What is the basic difference? Sorry? One is in the eastern side, one is in the western side? No. What you said is perfectly right. New Zealand is located along which type of a plate mountain? Convergent boundary. Iceland is located along which type of a plate boundary? Divergent plate. Only the nature of this plate boundary is what? Okay. Fine. So I've just given you two examples. One more example also, it is worth noting it. Very popular. Very, very popular. It is Yellowstone National Park. Yellowstone National Park, USA. So these are some of the regions in the world which is known for hot springs and geysers. Okay. We'll take a 10 minutes break. We'll come back. Okay. The second type of convergent boundary also we have just completed. Continent convergence, we have taken it. And coming to the last type of convergent boundary, we call them as what? Ocean convergence. Ocean convergence. What is ocean-ocean convergence? I'm talking about two oceanic crust which is going for convergence. Okay. And if you ask me, okay, what is the finest example of this oceanic convergence or ocean-ocean convergence where I have this Philippine plate and Pacific plate going for a convergence? See, plenty of examples are there, but what I am taking is what the prominent example, right? Now, approximately locate for this location may difference, Philippine and Pacific plate. In your atlas, if you're just looking for this Philippine and Pacific plate, okay, you find this Philippine plate. Philippine plate is oceanic crust. Pacific plate is also oceanic crust. This is the place what I have taken as this example, classical example of ocean convergence. Okay. Now here, both the crust is oceanic crust. Both are heavy in density. If that is the case, what may happen if at all if they are going for a convergence? Right? If not subduction, yes. Okay. I can take this word subduction. Both being heavy, together they can go for what? Subduction. Right? Say for example, they can make a subduction together. Okay. Both together can say for example go for kind of say for example they can move with the effect of what gravity as such. Okay. And if that is the case, here also you will be finding the formation of what? Trench. And sometimes what happens, this trench happens to be what? Very, very deep. Okay. And this is the place where you have one of the classical example of Mariana Trench. Okay. Where Philippine plate and the Pacific plate goes for a convergence. That's the place where you have the deepest trench of the world called as what? Mariana Trench. So one thing is there, right? We'll be having the formation of a trench. And can I say this place again will be having what? Destruction. If destruction is taking place, what will happen? Volcanic activity. And if volcanic activity is happening along the ocean floor, right? What we may have is the formation of what? Islands. Okay. Now we are talking about what type of a boundary? Ocean convergence. Now tell me, can I take Eurasian plate and Indo-Australian plate as this example? Can I take this Eurasian plate and Indo-Australian plate convergence as an example of ocean-ocean convergence? Yes or no? You know where is the Eurasian plate, right? You know where is Indo-Australian plate? When they converge with each other, what type of a boundary they make? Continent-continent convergence. I'm not denying the fact. Can the same boundary, can I take it as an example of ocean-ocean convergence? Natural hazards map. The place where I have Himalayas, convergent boundary, but both side of this convergence I have what? Land, right? Indo-Australian plate, continental crust. Eurasian plate, continental crust. Okay, fine. Right? I don't have a problem. Can you find this Andaman and Nicobar Island? Where you have this Andaman and Nicobar Islands, again you tell me, what exactly is the two plate that converges with each other to form this Andaman and Nicobar Islands? Andaman and Nicobar Island is also located along the same convergent boundary. What are the two plates which converges there? Again Indo-Australian plate, right? Again what? Eurasian plate, correct? Now, the same place, Eurasian plate and Indo-Australian plate at the place of Himalayas was an example of what? Continent-continent convergence. But the place of Andaman and Nicobar Island, I understand it is more like oceanic crust and oceanic crust going for what? Convergence. Very minimal example, but still I can take it as an example. Plenty of examples are there. Even North American plate and Caribbean plate, if I just take it for that case, right? For example, when I talk about Caribbean plate, right? And North American plate going for a convergence. Again, it is an example of what? Oceanic crust and oceanic crust going for what? Convergence. Plenty of examples are there. But which is the most prominent example, if you ask me, right? What we have taken as a classical example, right, is the most prominent example. Philippine plate, complete Philippine plate is oceanic crust, right? Then Pacific plate is what? Oceanic crust. But the feature formed will be more or less similar. So wherever I have such, say for example, a boundary exists, Subduction is going to take place. I'm going to have a trench. That is okay. But there also I'll be having destruction. There also I'll be having volcanic activity. There also I'll be having what? Islands. Okay. Right. I'll be having islands. And what will be the nature of these islands? Most of these islands will be volcanic. See here, this region, Philippines region, Indonesia region, right? We have so many islands, right? And all these islands, my dear friends, either they are, say, for example, resulted out of folding as a process, or they are what? Volcanic islands. Okay. So here, coming back to the discussion, when I talk about this ocean convergence takes place. The default feature will be trench. And I can also have the existence of an island. And most of the time, this island will be what? Volcanic island. Okay. Right. So what is the feature we have identified? Trench and island. What are the process we have it here? Obviously, because of destruction, we'll be having what? Volcanic activity. Any plate boundary you take it, I'll be having what? Three types of convergent boundary we have taken. Right? Three types of convergent boundary. What are the three types of convergent boundary? One, we were calling it as what? Ocean continent convergence. Whatever you see here is what? Is a feature and process of ocean continent. The second type of convergent boundary, what we have seen is what? Continent convergence. Whenever continent convergence comes in, certainly speaking, I will not have what? Oceanic feature. All this oceanic feature, I can rule it out. Okay. And again, I know continent convergence, subduction do not take place. I do not have what? Volcano. What is the only feature I'll be having? Hold mountain. Now let me talk about the third type of boundary. Third type of boundary is what? Ocean convergence. When ocean convergence comes in, I will not have what? Continent, both sides it is what? Ocean. What will be the feature I'll be having? I'll be having trench, I'll be having, that's it. Okay. So what you see in this table is what? The consolidated feature. This is what the maximum number of feature I can have it along what? Any convergent. Okay. The type of convergent boundary may be different, but this is the maximum. You can have it along any convergent boundary. Maybe more realistic or artistic image I'll just show you about these three types of boundary. It's a very old ringtone. Right? Nothing you can change it. That's what I'm saying. Okay, right. I'm just talking about these types of convergent boundary mediums. Different types of convergent boundary. Okay. Three types of boundaries we have seen. What is the first type of boundary we have seen? One side it is ocean and second side it is continent. Ocean continent convergence. Okay. Where I have subduction taking place. Because of subduction, destruction is taking place. I have this volcanoes that is formed along the, say for example, this convergence. I have the formation of what? Okay. The second type of boundary, what not taking place, what I understand is what? Volcanoes will not be there. Only this fold mountains. Okay. So what is the third type of a boundary we have seen? Ocean convergence. And talk about ocean convergence, yes, both being heavy intensity, at least one plate will be going for a subduction. That will be resulting in a destruction. Then apart from having a trench, I can also have what? Volcanic islands. Okay. So these are the different types of convergent boundaries what we have seen. Okay. Now I am moving on to the next type of boundary. You call them as what? Divergent boundary. Again, when it comes to divergent boundary, which is the most commonest divergent boundary? Which is very common? Oceanic divergence, right? What do you call them as what? Either you call them as oceanic divergence or you call them as ocean divergence. Can you give me an example of ocean divergence? Divergent boundary in the ocean. See, once, if you remember, we were comparing fold mountains versus block mountains. Where we'll be having the formation of fold mountain? Convergent. Where we'll be having block mountain? Divergent. But here, today when I talk about young fold versus young block mountains are very minimal in numbers, right? I can have few names, but the extension of these mountains are very limited. But what dominates today's map of the world is what? Fold mountain, young fold mountains. Default name of a mountain will be an young fold mountain. The question is, why young fold mountains are very common, whereas block mountains are not so common? Two reasons are there. Few classes before we talked about block orogenesis, and there I said, For block mountain to be formed, it is condition specific. Along any divergent boundary, what is the default feature that is created? What is the default feature that is created? Rift valley. Along with the rift valley, there is a chance that I may have what? Block mountains. Am I right? So somewhere, everywhere, heave alone takes place, rift valley. Heave takes place along with the downward throw, rift valley. Heave takes place along with downward throw and upward throw. Only then I'll be having what? Block mountain. That's the reason we said along convergent boundary there shall be a fold mountain basin. Correct? And along a divergent boundary there may be a block mountain. This is one reason why block mountains are not so common. Okay. If you have a convergent boundary, there I'll be having a fold mountain. That is not the case with block mountain. Number one. Number two, I know the fact that net convergence is always equal to net divergence. All the convergent boundaries of the place you take it, right? Of the world you take it, right? Somewhere they are convergent, right? All divergent boundaries of the world you take it, somewhere, right? The net convergence will be equal to what? Net divergence. Or in general, my dear friends, if one plate is moving, making a convergent boundary with one plate, this plate may make a divergent boundary with what? Another plate. Not necessarily every time it happens. But life also you can see that if somebody is going away from you, it means something else is attracting them. Right? It means I'm just telling you, right? Okay. Now what I'm just trying to say, net convergence versus net divergence, you take it, right? I understand they are equal. Right? If that is the case, logic says if I have, say for example, few set of fold mountains, I should have equal number of block mountains. But again, why block mountains are not common? Very simple. Because most of the divergent boundaries today I have where? Located in the oceans. All that what I am marking here, they are divergent boundaries of the divergent boundary. They are located, predominantly they are located in what? Ocean. Divergent boundary of the ocean will not result in block mountain. They will be resulting in a feature called as what? Mid-oceanic ridge. Okay? Right. So having said that, coming back, I asked you an example, right? Any example in the ocean you take it, that will be an example of what? Oceanic divergence. For example, North American plate and Eurasian, what kind of a boundary? Oceanic divergence. South American plate and African plate, oceanic divergence. African plate, to be very precise, Somalian plate and Indo-Australian plate, divergence. Indo-Australian plate and Antarctic plate, divergence. African plate and Antarctic plate, divergence. Nazca plate and Pacific plate, divergence. Pacific plate and Antarctic plate, again what? Divergence. What dominates the ocean floor is what? Divergence. Okay. Continental divergence is very, 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 very bad. Okay. Now we'll try to understand. If at all, if divergence is taking place, what will happen? Okay. See, that's the reason specific example I'm not giving it, because any ocean you take it, that's going to be an example. Correct. Now I know the fact that oceanic crust is very thin. Somewhere I told you, right? We talked about the thickness of this crust. Somewhere we said where I'll be having maximum thickness, where I'll be having minimum thickness. Where you have minimum thickness? We have taken as a fact. Wherever I have oceanic divergence, that's the place where the thickness will be what? Very less. Okay. In that way, what is a kilometer? Somewhere we said it is only 5, somewhere around 5 kilometers. That is crust. Lithosphere is also going to be what? Very, very thin. So if that is the case, if this very, very thin crust opens, somewhere if it is going for a divergence, can I say the probability of this crust completely opening up is what? Very high. If this crust opens up, what will happen? Oceanic crust is there, right? Very thin. Am I right? It is going for a divergence. I said probability of this crust opening is very high. Assume that it opens up. What can happen? Magma will come out. Am I right? Now you may wonder, why only magma should come out? Why this ocean water cannot go inside? Am I right? It's obvious. Everybody can have this doubt. Okay. Reason is very simple. Density difference. Magma is more denser. Water is less in density. Am I right? Denser, say for example, substance can enter what? A rarer substance, not the other way around. Okay. So that's the reason magma comes to the ocean floor, not the water getting into what? Astronaut. So as and when this magma starts raising, right? Say for example, it completely opens up. Crust opens up. As the crust opens up, this magma rises, right? As and when the magma reaches the surface, that is ocean floor, what will happen to the magma? Magma will solidify almost instantaneously, because every side it is surrounded by water. Again it opens up, again the magma comes out. Even before it spreads horizontally, this magma will go for what? Solidification, right? Again it will be going for solidification. Again it opens up. slowly, steadily what happens? It will start growing in its height. The question is, why this feature is growing in its height? Why not horizontally, if you ask me? As I said, reason is very simple. As and when the magma comes to the ocean floor, all side it is surrounded by what? Water. So this solidification process is almost instantaneous. Even before it spreads out horizontally, it will go for what? So it will start growing vertically. And this mountain-like feature, what is creating, right? This divergence is creating, we call them as what? Mid-oceanic ridge. Or simply you call them as what? I want you to compare two maps. Map which is given in page number 118 versus page number 101. Page number 101, you have these maps of the oceans on it, right? 5 oceans, 100 and 101. If there in 101, Indian Ocean map is given, Atlantic Ocean map is given, and Pacific Ocean map is given. Orient Black Swan, Atlas, you don't have a separate map for ocean. You can refer your world physical map for that case. Okay. Now, my difference. Wherever you have a divergent boundary, for example, right? We have a divergent boundary in the middle of Atlantic Ocean, right? Middle of Atlantic Ocean, exactly you overlap. You have a continuous, say, for example, mid-oceanic ridge in what? Middle of Atlantic Ocean, and accordingly, this ridge is called as what? Mid-Atlantic ridge. How to identify in your atlas? It will be shaded light blue in color, right? Light blue, almost looks white in color, right? In the middle of the ocean, light shaded blue, right? You have this mid-Atlantic ridge. But what is very important here, the specific name what it takes is important. Okay, it is called as mid-Atlantic ridge, no denial, but it takes a specific name. Northern basins, this ridge is called as what? Dolphin ridge. Can I find this dolphin ridge? Within bracket, it is written as what? Dolphin ridge. And southern basin, the same ridge is called as what? Challenger's ridge. These names are very important. Okay. I've just given here, in the names I have just given here, the northern basin, this ridge, you call them as what? Dolphin ridge. Southern basins, you call them as what? Challenger's ridge. Similarly, my dear friends, where this Nazca plate and South American, Nazca plate and Pacific plate goes for a divergence. Again, here you find a ridge. In your atlas, it is given as what? East Pacific ridge. But more than that, the specific name is very important. What is the name it takes? What is the specific name? Very good. It is called as Albatross Plateau, or simply you call them as what? Albatross ridge. You call them as what? Albatross ridge. Fine. So one feature we have taken it, wherever you have this oceanic divergence taking place, right? Along the place of oceanic divergence, what is the default feature I'll be having? I'll be having this mid-oceanic ridge, number one. Number two, this mid-oceanic ridge is going to grow vertically. What is the reason for its vertical growth? We have justified. Can I say this growing ridge can one point of time can emerge above mean sea level? If it is emerging above mean sea level, it becomes an example of what? Islands, right? It becomes an example of islands. And of course, I understand this island, I should call it as what? Volcanic island. Either I call them as volcanic island or I call them as what? Hotspot island. What is hotspot island? You call them as volcanic islands and hotspot islands. Can you give me one example where this ridge has grown, somewhere emerged above the mean sea level, and say, for example, eventually it has become an island, some significant island? Can you give me one or two names of it? Very good. Hawaii is a hotspot island. Accepted, but more than Hawaii. We'll discuss about Hawaiian islands, but more than Hawaii. You're there along Dolphin Ridge. You know where is Dolphin Ridge? Assume that slowly, steadily, the Dolphin Ridge is growing. At one point of time, emerging above mean sea level and becoming an island. Obviously, this island is volcanic island. That's the reason this island has taken the nickname called as what? Land of ice and fire. Iceland. Iceland is located exactly where? Along this ridge, right? The northern part of this ridge you will be finding what? Iceland. In page number 101, top, say for example, putting yourself in the almost, say for example, top of this page. Or page number 118, somewhere you can verify the fact. Along the divergent boundary, oceanic divergence, you have this Iceland which is located. Already we discussed about. I was talking about geysers, that time we discussed about the locational aspect. Okay, right, my difference. Now, default feature will be mid-oceanic grids. Then I'll be having the formation of island, and this island will be what? Volcanic islands, or sometimes I also call them as what? Hotspot islands. Okay. Now, if this island is larger, can I say I can also have this rising magma creating a separate volcano? This island itself is volcanic island. I'm not denying the fact. But apart from that, if it is, say, for example, very large in its extension, I can also have what? Volcanoes in it. Okay. It means, say, for example, this region, I may have what? Volcanoes. Okay. Come to Iceland for a minute. Page number 76. Map of Europe. You're there in physical map of Europe. Physical map. Putting yourself in the top left side of this atlas. Top left. The northwestern side. Almost at the top of this page, right? You find what? Iceland. In Iceland, only one volcano is given. Only one volcano is given. Can you find this volcano called as Mount Hekla? Mount Hekla. Mount Hekla is a volcano. But more than Mount Hekla, let me give you some of the classical example of this hotspot islands and volcanoes. We have this island called as Hawaii Islands. Have you heard about this Hawaiian Islands? Hawaii? Hawaiian Islands. Recently it was there in news. Why? See, volcanic eruption is one, forest fire, bushfire, right? The complete island has been destroyed because of this bushfires or forest fire. Okay, fine. Hawaiian Islands. Hawaiian Islands politically belongs to which country? USA. Now comes the question, where is Hawaiian Islands? Don't tell me USA. Okay, first we'll locate this Hawaiian Island. World political map. Page number 102. You are there in world political map. Once you are there in this world political map, you find North America. Right? Once you identify North America, there, can you find this line called as Tropic of Cancer? Start traveling along this Tropic of Cancer towards western side, towards your left side. Right? You will be entering Pacific Ocean and start traveling along this line. This line will take you to what? Hawaiian Islands. Okay. Hawaiian Islands, politically they belong to what? Politically they belong to US. Okay. So where is Hawaii? Hawaii is somewhere here. It is not given here. This is the place where you have this Hawaii Islands. Hawaiian Islands. Along this Tropic of Cancer, Hawaiian Island is located. See, historically also Hawaiian Island is very, very important. Geographically it is very important. Historically also it is very, very important. Have you heard about this place called as Pearl Harbor? Pearl Harbor, right? Japan, when talk about, say, for example, Japan, how exactly Japan invited USA to participate in World War II, right? So Japan has given the formal invitation to Hawaii saying that kindly come and participate in World War II. So as a responsible citizen, you cannot be outside this war, they said. Okay. Now, how exactly they have done it? They have, say, for example, bombarded what? Pearl Harbor. Of course, it has been retaliated very, say, for example, vigorously. Okay, whatever it is the case, right? And the two, my difference, Japan, see, where is Japan and where is Hawaii? See the efficiency of this jet plane. Am I right? Entire Asia they have surpassed. Entire Europe they have surpassed. Atlantic Ocean also they have surpassed. Entire North America without bombing they have surpassed. Then we went to Hawaii and came back. Is it the case? No. Okay. It means we are wasting time. Okay. Now, what we'll do, you just come to a separate map of Hawaii. There is a separate map for USA. I think page number 86. Go to page number 86. There is a separate map for USA is given. Orient Black Swan is not given, but Oxford it is given, right? Now, once you are there in the separate map of USA, the bottom of this page you have two inert maps, small map. One side you have Alaska given, another side you have this islands of Hawaii is given. Right side, bottom of this page, You have this Hawaii. Hawaii is given. Can you find Hawaiian Islands? Right. There, if you're looking for this Hawaiian Islands, there you may also find what? This Pearl Harbor. Can you find Pearl Harbor? Okay. Fine. Now, Hawaii is an example of hotspot island. I'll tell you what exactly is hotspot island. Okay. Hawaii is an example of hotspot island located along the oceanic divergence. Hawaii is an example of intraplate divergence. Okay. Now, see here. If island is large enough, somewhere I said there is also a possibility that I can have what? Individual volcanoes. You have some of the prominent volcanoes here. Can you find the mountains like Mount Mauna Kea? Mount Mauna Kea. Very near to it, can you find one more mountain called as Mount Mauna Loa? Mauna Loa, Mauna Kea, Mauna Loa, all these are mountains, volcanic mountains. Okay, they are volcanoes. Okay, right. So Hawaii, volcanic islands, hotspot islands. Within this hotspot islands, we have taken this volcanoes. One small clarification. Convergent boundary also, we talked about the existence of what? Volcanoes. Divergent boundaries also, we are talking about what? Existence of volcanoes. Convergent boundary, why exactly we had this volcano formation? Why? Pressure. Am I right? Destruction has created a pressure, right? So, for example, when the magma load started increasing, this magma started coming to the surface. So, there I have volcanic activity because of what? Pressure. Am I right? Now comes the question, divergent boundary, why do we have volcano? Simple, because crust is opening up. There, say for example, magma is trying to come out with a great difficulty. Here crust says, alright, don't worry, I'll help you out. Just it opens up, magma comes to what? Surface. If that is the case, will there be difference when it comes to intensity of volcanic activity between the volcanoes of convergent and divergent? Obviously, yes. Which volcanoes will be intense in nature? Convergent boundary. They belong to explosive type. Divergent boundary, they belong to what? Quiet type. They'll not even disturb. Right? Sometimes, okay, of course, very recently Hawaii was devastated by forest fire. But until recently, my dear friends, this volcanic eruption in Hawaii itself will be a tourist attraction. Two examples I'll give you. Have you heard about this island called as Bali Island? Bali Island. Bali Island, Indonesia, is a favorite honeymoon destination of the world. Right? Now, what happened? I'll show you where is Bali. Okay. Most of you want to go to Bali, at least I'll show you where is Bali. Right. Okay. Now, page number 66, map of Asia. Why I am talking about Bali, I'll tell you. Right. Can you find Indonesia? One by one. Can you find one island of Indonesia which is very, very close to India? Very close. This island you call them as what? Sumatra. Sumatra Island is very close to India. Now you may wonder what is this you're saying very close to India? Because Andaman is also what? India. Okay. Very close to Andaman and Nicobar Islands. Can you find Sumatra? Once you identify Sumatra, like an arc you travel towards the eastern side. The next island what you encounter is what? Java Island. Can you find Java? Right? Once you identify this Java Island, the very next island what you have is what? Bali. Right? Slightly you have to press your atlas, only then you can see Bali. Right? Okay. Can you find this Bali? Exactly the eastern side of this Java Island, you have this Bali Island. Physical map, very easily you can identify. Just look for Sumatra. Once you identify Sumatra, then slightly venture to Java Island. The next island what you have is what? Bali Island. Okay. Now, why I have taken this Bali Island and tell you my difference. See, Bali Island, yes. Coming back here. Okay. Later we'll reserve a date for Bali. Okay. Now, what I'm just telling you, when I talk about Bali Islands, my dear friends, in Bali Island, we have a volcano called as Mount Agung. Mount Agung. Right? Way back in 2020, later part of 2020, this Mount Agung was about to erupt. It was a dormant volcano. It was somewhere. It started almost, say, for example, erupting. Right? Same time, what happened? Hawaiian Islands, there was one more volcano called as Mount Mauna Kea. Mauna Kea was erupting. Okay. Now what happened, my dear friends? Both the places, two mountains. For example, Bali Island, Mount Agung was erupting. Hawaiian Islands, Mount Mauna Kea was erupting. Same time, same time. But what happened when Mount Agung erupted? It was given, say for example, general advisory was given to the tourists that don't go to Bali Island. Just because, say for example, advisory was given to, right, not to go to Bali Island for the simple reason, because say for example, this volcano can possess what? So Bali Island was kept out of what? Tourist destination, right? Somewhere people were somewhere refrained going toward Bali Island when this Mount Agung started erupting. So one volcanic eruption forced, say for example, people out of this island and somewhere stopped people from going to this island. On the other hand, what happened? Mount Mauna Kea exactly did the opposite. Mount Mauna Kea, on the other hand, started attracting the tourists, right? Say for example, Hawaii said, don't go to Bali Island, right? Come to what? Hawaii. Now the question is, both are volcano, both are erupting, right? But one is possessing a threat, another is becoming a kind of a tourist attraction. See, tourist attraction means you cannot go and play with the magmas of volcano, right? So what I understand here, at least I can have that visual appeal. Okay, I can see, I can enjoy it, as simple as this. Okay. The question is, why exactly one volcano is possessing a threat and one volcano, another volcano is not possessing a threat, if you ask me? The basic reason lies in what? The type of a boundary. Mount Agung is located along what? Which type of a boundary? Destructive boundary. Alright, convergent boundary. When I talk about Mount Mauna Kea, it is located along what? Divergent boundary, constructive boundary. So obviously, the nature of the boundary will determine the volcanic activity. See, for example, Pacific Ring of Fire is known for what? Continuous subduction zone and destruction zone. The volcanoes of Pacific Ring of Fire will be what? Intense. Whereas the volcanoes, what I have along the divergent boundary, actually they belong to what? Right? They may not ordinarily disturb the, say for example, human settlements as such. Okay, right. So we talked about mid-oceanic ridge, we talked about islands, we also talked about what? The formation of volcanoes. One small deviation, my dear friends. Repeatedly, we were talking about this word called as what? Hotspot. So we'll try to understand what exactly is hotspot. See, hotspot itself, say for example, this clarity of this concept is not so great. Okay, right. So let me not complicate the concept of hotspot, right? But somewhere I'll try to make it in a simpler fashion. What is this hotspot? See, hotspot is more like a permanent opening in the lithosphere. So generally, these hotspots you will be finding along what? Oceanic divergence. Okay. See, for example, I told you hotspot is more like a permanent opening in the lithosphere. And you find it along oceanic divergence for the simple reason. Oceanic crust is already thin. And when I talk about oceanic divergence, almost this crust opens up. So having, say, for example, a opening in this region is what? Very, very common. Okay. So hotspot, as I said, it is more like this permanent opening in the lithosphere. Now tell me, my dear friends, if you have a permanent opening in the lithosphere, what can happen? Very good. Magma can rise towards the surface of the, am I right? This rising magma is sometimes also called as what? Mantle plume. Okay. It is also called as mantle plume. And one more thing, this rising magma, once it reaches, say, for example, the lithospheric, sometimes what happens? This can also create a mantle head or plume head, and it can move the, say, for example, plate from one plate to another, right? That much detail will not take it, right? So, what do you mean by mantle plume? The rise of magma, you call them as what? Mantle plume. And this rising magma can create what? Large number of small islands, dotted islands, and these dotted islands, you call them as what? Hotspot islands. So kindly write a small heading called as hotspot. A permanent opening in the lithosphere. A permanent opening in the lithosphere is called as hotspot. Actually, slightly I am modifying the concept for the simplicity. Okay. The last statement, what I have said, don't write it. Okay. Okay. Now, what I said, a permanent opening in the lithosphere is called as hotspot. It is generally identified. It is generally identified along oceanic divergence. Along oceanic divergence. Mantle plume or magma rise. Mantle plume or magma rise is the commonest activity, that happens along any hotspots. The rising magma eventually creates many small islands called hotspot islands. Okay. So what is hotspot? Somewhere we have an idea, right? An example of hotspot island. See, I have given you the simpler version of these hotspots. Okay. Somewhere I told you that it is a permanent opening. But there is one more theory. According to that theory, they say whenever we just talk about hotspot actually created by this mantle plume. And they say mantle plume is a rising magma. But this magma, according to them, do not come from asthenosphere. According to them, they actually come from what? The outer core, my dear friends. I'll show you an image. Right? So if I just somewhere talk about this mantle plume, they say for example, very hot section of magma will be rising. But according to this theory, they say that actually they rise from core. Am I right? They rise from core and eventually say, for example, they crosses all the layers and they'll be reaching what? The surface, or the say, for example, they will be reaching this lithosphere or crust, right? Because they are extremely hot, what they believe that they'll be, say, for example, melting this part of lithosphere at one point of time, it can make a permanent opening. Okay, this is another theory. Okay, so according to one theory, say for example, they say that this plume, mantle plume, they don't rise from asthenosphere, they rise from what? Outer core. Okay, see, and one more thing, there are different school of thoughts, right? But it is more of a belief. We have not, say for example, confirmed it yet. Okay, fine. Now, what is hotspot? Everything we have taken it, and to consolidate, my dear friends, what are the features generally we identify along any oceanic divergence? As I said, the most commonest feature will be what? Ridge. Ridge growing above mean sea level becomes island. Either you call them as what? Volcanic, or to be very specific, you call them as what? Hotspot island. If this island is large enough, I can also have what? N number of other volcanoes. Okay, that's all about this oceanic divergence. Now, one small diversion, right, or deviation. Our deviation is always within this subject. Okay, now, if I ask you, which is the highest mountain in the world? Which is the highest point or highest mountain in the world? Without any second thought, you should be saying that it is Mount Everest. Okay. So, which is the highest mountain in the world? You know, when I talk about the highest mountain, it is what? Mount Everest. Okay. Himalayas, but Mount Everest is the most elevated peak, which almost stands at the height of what? 8848 meters. Few books says it is 8850 meters, whatever it is, right? Now I have a small, say for example, slightly I'll change the question, right? Instead of highest, let me ask you this term called as what? Tallest mountain in the world. I'll give you a clue. It is not Mount Everest. The K2 is highest peak in India. Am I right? Substantially, when I talk about K2, my dear friends, what is the height of K2? It is 8,611 meters, right? Substantially, it is smaller than what? Right? Mount Everest. If you want to make K2 a tallest mountain, maybe I can install one mobile tower there. Am I right? I can make it okay. Whatever is the case. Now, what is the tallest mountain in the world? Highest mountain is Mount Everest. What is the tallest mountain? Let me tell you, the tallest mountain, it is regarded as Mount Mauna Kea. Now we have a question, what is this Mount Mauna Kea? Just look at the height. In your atlas, height of Mount Mauna Kea is given as what? Somewhere approximately it is given as 4,200 and how many meters? Approximately 4,200 meters. What is height given? 42? Okay, 4205 meters. Okay. Approximate height given in your atlas is what? 4,200 meters above mean sea level. Now comes the question, with 4,200 meters, how can you call it as the, say for example, tallest mountain? Clarity, when I just talk about the highest mountain, this height is calculated from what? Mean sea level. With this height, Mount Everest stands at the height of 8848 meters, right? When I talk about the tallest mountain, the height is not calculated from the mean sea level, it is calculated from the base of the mountain. And this base of the mountain is located where? Floor of the Pacific Ocean. Okay. What lies above the mean sea level is somewhere around 4,200 meters. What lies below the mean sea level is nearly 6,000 meters. So if I just calculate the height is more than what? 10,000 meters. That's the reason I said the tallest mountain is what? Mount Mauna Kea. Because I have just taken the example, I have just given you this. Right. And one more thing, disclaimer says, we have also added the disclaimer. This answer is debatable. Okay. So don't conclude it, but still this is a popular way of saying. Okay. One more volcano also, I'll just take it for this case. For example, we know the fact that Earth's radius is not uniform, right? Earth's radius is not uniform. That's the reason even the small g, gravitational attraction or the acceleration due to gravity is also not uniform throughout the Earth. Throughout the Earth. So what I just want to tell you, the Earth's radius is not uniform, number one. And number two, the surface of the Earth is also not uniform. It means different places on the surface of the Earth will make a different distance with respect to what? The center of the Earth. Am I right? It means every point will be having different distance or radius. In that way, which is that point which is located at the maximum distance away from the center? I'll put it this way. Which is the farthest point on the surface of Earth with respect to the center of this Earth? See, sometimes I have mountain peaks, sometimes I have valley deeps, I do have trenches. Point of trenches will be close to center of the Earth. Mountain peaks will be far away from the center. If that is the case, all different infinite points on the Earth, if I just take it, and if I look for that place on Earth, which is located at the maximum distance from the center of the Earth, that farthest distance, right? What is that farthest point? Neither it is Mount Everest nor it is Mount Mauna Kea, but this mountain called as what? Mount Chimborazo. Chimborazo. You tell me why? How Chimborazo can be that farthest point? Everything is there. Where exactly Chimborazo is located? The country called as what? Ecuador. Ecuador is the country where I have what? Equator as a line passes. Am I right? Chimborazo is almost located above what? Equator. And one thing I know, my dear friends, entire Earth, where exactly I have the maximum radius? Equator. Equator, there is a bulge. Already the radius is more at equator. Along with this bulge at equator, now I have what? One mountain, right? So all this fact taken together, if I just take it, the farthest point on the surface of the Earth from the very center is what? Mount Chimborazo. I am taking this fact for the simple reason, both these facts, they are volcanoes. That's the reason I am just taking. Right. So all about, it is just a fact. If you want to take it, you take it. Right. Okay. Now all about oceanic divergence we have taken it. Now coming to the last type of divergent boundary, you call them as what? Continental divergence. Continent divergence, or simply you call them as what? Continental divergence. Classical example is African plate and Somalian plate. Instead of writing it as African plate, I can write it as what? Nubian plate, right? And say, for example, this Somalian, Nubian and Somalian. It is in news, right? Somewhere one side you have this Nubian plate, another side you have the Somalian plate. Both are going for what? Divergence. Both the side of this divergence, what I have is a continental. Right. Now you tell me some of the facts already you know. wherever continental divergence is taking place, what will be the default feature? Rift Valley. Very good, right? Because I understand any divergence, the default feature will be what? Rift Valley. Accepted. Now the question is, do we have a Rift Valley in this region? Answer is yes. This Rift Valley, you call them as what? Collectively, you call them as what? Great African Rift Valley. Page number 88. Not 88, 92. 92. Orient Black Swan. Bottom of this page, you will be finding a separate map given. Bottom left side, you will be finding this Great African Rift Valley is given. Oxford Atlas, you know where exactly this African Rift Valley is located. You'll be finding that red lines are marked, right? This red marked lines are nothing but what? Rift Valley region. Individually, you can find some names. Can you find the Rift Valleys like East Rift Valley, Mid Rift Valley, West Rift Valley? So collectively, all these Rift Valleys, collectively you call them as what? Great African Rift Valley. This is the largest Rift Valley systems of the world. You know it. Okay. Now, the default feature is Rift Valley we said. Right. Along with the Rift Valley, what else I can find? Block mountains. Okay. Now again, somewhere descending along this Rift Valley, can you find some block mountains here? Pronounce it, it says that I am there in Africa, right? You call this mountain as what? You have this Mutumba and Uchinga, right? See, all these names, this is not the first time we are seeing it. Okay. I think third time or fourth time we are seeing it. Okay. Now, two features we have taken, my friends. Two features. What are the features we have taken it? We have identified the formation of Rift Valley. I'll be having Rift Valley. Along with the Rift Valley, I may have what? Block mountains. I have just given the name Mutumba and Uchinga. Finest example. Now, can I say, like oceanic crust, there is also a chance that continental crust can also open up. But only thing is that probability is very less. Oceanic crust is thin, so the probability of oceanic crust opening up was very, very high. Very easily it opens up. But continental crust, that probability is not so great. But still there is a chance that it may open. Right? Assume that somewhere it is opening. If it is opening up, what can happen? The same process. Magma can come to the surface, but one difference. When magma comes to the surface, unlike oceanic divergence, here you will not find, right, this magma feature growing vertically. Rather, you'll be finding this lava will start flowing what? Horizontal, right? Larger extent it will be covering, and post solidification it will form a lava plateau. Oceanic divergence versus continental divergence, both the places what comes to the surface? Magma. But one place this feature is growing vertically, another place the feature is growing what? Horizontally. The ridge is a vertical feature, lava plateau is a horizontal feature. Now tell me what makes the difference. Why one place it is growing vertically, one place it is growing horizontally? Simple, time of solidification. Underwater, by the time magma comes out, everywhere it is water, so the time of solidification is more quicker. Before even it spreads horizontally, it goes for what? Solidification, correct? Here it is not the case, right? It comes to the land, right? It takes its own time. It will be spreading a larger area, right? Then only it will be going for what? Solidification. So what makes the difference is the time of solidification. Okay. So you'll be having a lava plateau. Now here, map of Africa. Can you find a lava plateau? Better I'll show you the lava plateau. Put yourself in map of Africa. Can you find this landlocked country called as Ethiopia? Northern parts of Africa. You're there in northern parts of Africa. Just look for this Ethiopia. On the face of it, it looks as though Ethiopia is having a coastline. But taking a very close look, you'll be finding that Ethiopia is a landlocked country. Can you find Ethiopia? You're there in Ethiopia, physical map. Can you find a feature called as Ethiopian Highland? Ethiopian Highland. Ethiopian Highland is a lava plateau. Minor example. Just want to tell you that you will be having a lava plateau. Okay. So the third feature also we have identified, my friends. What is the third feature? Right? We have this formation of lava plateau. Lava plateau. And finally, if entire crust can opens up, if the magma can come to the surface and form lava plateau, can I say there is also a chance that this rising magma can come to the surface and form what? Volcanoes. Okay. And you tell me what will be the nature of this volcano? Quite or intense? Quite. Any diversion boundary, quite. Any conversion boundary, what? Intense, right? Now some of the classical examples. Can you find this country called as Kenya? Kenya? Can you find this line equator? Follow this line equator, country Kenya. Right above this equator, can you find this mountain called as Mount Kenya? Mount Kenya is a volcano. But more than Mount Kenya, slightly south of it, Kenya-Tanzania border, within Tanzania, you have one of the most default and very popular names of volcano. You call it as what? Kilimanjaro. Kilimanjaro is a volcano, a quiet type of volcano. Okay. So all the features along this continent divergence we have taken. So what are the features? Any divergent boundary, I'll be having Rift Valley. Along with the Rift Valley, I may have what? Block Mountain. If the crust completely opens up, magma can rise to the surface and spread horizontally to form what? Lava plateau. If magma can come to the surface and form lava plateau, it can also form what? Volcanoes. Okay. So 4 features we have taken it. Okay. And last type of boundary, we call them as what? Transform boundary. Okay. See here, only one classical example of transform boundary we have. I don't want to leave this topic all the way in middle. Okay. 10 more minutes I'll take, with or without your permission, whatever it is the case. Right now, we'll complete it. Okay. Now, transform boundary made. Classical example of a transform boundary, I have Californian plate and North American plate making a kind of a boundary, right? Somewhere symbolically we say it is more like these boundaries slide past each other, right? What you're seeing here, 2 boundaries, right, moving in such a way that they are slide passing each other. Okay. A classical example, I said North American plate and Californian plate, right? Relative motion. It shows it is more like what? It is kind of what? Kind of, it makes a transform. Now, where is this Californian plate? I'll show, right? Small plate, not given in your atlas, but come to map of North America. 82, little quick, right? You're there in map of North America. Can you find Mexico? You're there in Mexico. The western side of Mexico, can you find a gulf called as Gulf of California? Gulf of California. Adjoining Gulf of California, can you find a peninsula? What is the name of this peninsula? Californian Peninsula, right? I have Californian Gulf, I have Californian Peninsula. Now what do you do? Adjoining political map, right? Just move north of this Californian Peninsula and Gulf. You'll be entering USA. You'll be crossing this Rio Grande River, right? You'll be entering what? USA. And what is the state in USA called as? What is the name of the state? In USA, what is the name of the state? California. Am I right? So this, when I talk about, say, for example, this Californian plate, where all I have, this peninsula, I call them as what? Californian Peninsula. Gulf, you call them as what? Californian Gulf. State, you call them as what? Californians. So where is Californian plate? Very simple, all California. Am I right? Right? Except this Californian pistas. Am I right? So what I understand that all Californias you take it, that is what you call them as what? Californian plate. Okay. Right. Now, this transform boundary, if it is there in the land, right? If the transform boundary is there in the land, as of today, though I say transform boundary is different from divergent boundary, but whatever features I find along the divergent boundary, the similar feature I'll be finding along what? Transform boundary. Right? For example, continental divergence. What are the features we have identified? What is the default feature I'll be having? Rift Valley. Here also I'll be having a Rift Valley. Right? You have a Rift Valley called a San Andreas fault, not given in your atlas. That is not your fault. Okay. What I'm just trying to say, right? Very, very small, say for example, fault line or a fracture zone that is created. Okay. Only the name you take it. San Andreas fault, California. Rift Valley. Along with the Rift Valley, what else you can have? I should have what? Block mountains. Now comes the question, do you have a block mountain here? See here, actually speaking, the place what you are searching is what? I have the stretch of Rocky Mountain. Rocky Mountain is what? Fold mountains. But along the stretches of Rocky Mountain, if you remember, I have a small piece of block mountain. You call them as what? Sierra Nevada. Right? So why I have Sierra Nevada as a block mountain among the fold mountain stretch? It is all because of this transform boundary what we have. right? San Andreas Fault as a Rift Valley we have taken it, right? Sierra Nevada as a block mountain we have taken it, and now comes the question, right? This region should also have what? Lava plateau. Can you find Sierra Nevada as a mountain? If you find Sierra Nevada as a mountain, if I'm not wrong, slightly northern side of it, can you find a plateau called as Columbian Plateau? Columbian Plateau is a lava plateau. Still finding North American map, right? Okay. Columbian Plateau, right? Just north of it. Then again, right, I have this Columbian Plateau because of the time constraint. This place, maybe after the class also you can search. Okay. Now say for example, if lava plateaus can be formed, I can also have what? Volcanoes. Again, this volcano should belong to which type? Quite. For example, you know Sierra Nevada mountain, right? Once you have identified Sierra Nevada, put yourself in the northern tip of Sierra Nevada. Just northern boundary, northern tip of Sierra Nevada. You find a mountain called as what? Mount Shasta. Similarly, southern tip of Sierra Nevada, you find this Mount Whitney. Okay, right. So whatever features I have it along continental divergence, the similar feature I'll be having it along what? Transform boundary. Okay. Now what I have done, my dear friends, here, I have consolidated all the features, right? For example, convergent boundary. How many different types of convergent we have? 3 types. Ocean, continent, 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 ocean, ocean. Whenever I have a convergent boundary, ocean side I'll be having a trench, continental side I'll be having what? Fold mound. Subduction will lead to volcanic activity. Eventually on the land side I'll be having volcano, right? On the side of oceans I'll be having what? Right. Then I said, when I talk about continental convergence, my dear friends, I should bring only what? Fold mountain and volcano. There also I said continent convergence, right? We do not have volcanoes. Accordingly, the only feature what I'll be having is what? Fold mountains. And when I talk about ocean convergence, I should bring only what? Oceanic features. And what are the oceanic features? It is trench and island. Correct. Now, when I talk about divergent boundary, oceanic divergence. Oceanic crust opens up, magma comes to the surface, slowly, steadily, vertically it grows, forms what? Mid-oceanic ridge. Ridge emerges above mean sea level to create what? Islands. You call them as hotspot islands. The islands are large enough, it can also create what? Volcanoes. Am I right? Continent divergence. The default feature I'll be having a Rift Valley. Along with the Rift Valley, I may have what? Block mountain. If the crust opens up, I'll be having what? Lava plateau that is being formed. And the magma can also come to the surface to form what? Volcano. Whatever the feature I have along continent divergence, the same or similar feature I'll be having along what? Transform boundary, right? And when it comes to all plate boundary, what is universal? Earthquake is universal. But volcanic activity, one small clarification. Almost all types of plate boundaries has volcanic activity. What is the only plate boundary which do not have volcanic activity is what? Continent convergence. See, what is the other name for convergent boundary materials? Convergent boundary, you call them as what? Destructive boundary. To be very precise, you don't call it as a destructive boundary, right? This convergent boundary can further be divided into destructive boundary and collision boundary. Only where destruction takes place, right? You can call them as destructive boundary. So what can be the destructive boundary? When I talk about ocean continent convergence and ocean convergence, it means any convergent boundary, at least one crust should be what? Oceanic crust. Because I know only oceanic crust will go for what? Subduction. Only this oceanic crust will get what? Destruction. Where I do not have this oceanic, where I have this continent convergence, like Himalayas, you don't call it as a destructive boundary. Rather, you call them as what? Collision boundary. So all convergent is not destructive. Only where the convergence has oceanic crust in it, I can call it as what? Destructive. Okay. So before we conclude, right, let me show you some of the questions which is asked in the past. See whether you can attempt it or not. Discuss the geophysical character of circum-Pacific zone. What all you can write? Okay, you can write. Am I right? Something like that. Okay. Whatever we discussed about the circum-Pacific zone or Pacific ring of fire, that I have to. Define mantle plume and explain its role in plate tectonics. Only the thread you use. What is mantle plume? Magma rays. Where mantle plume is common. Hotspot. I have to talk about hotspot. Explain the formation of thousands of islands in Indonesia and Philippines. Indonesia and Philippines is located where? Along the active tectonic boundary, along the convergent boundary, along the destructive boundaries. If that is the case, these islands will be predominantly what type of islands? Volcanic islands. I have to talk about the formation of this island. What are the different plates which is converging to form these islands? Why are world's fold mountain system located along the margins of the continent? Here the margin of the continent means plate boundary of a continental crust. Somewhere I have to say that how and why the fold mountain systems are formed. Okay. Then they say bring out the association between global distribution of fold mountains, earthquake and volcanoes. Somewhere I can say wherever I have fold mountains, that is going to be known for what? Earthquakes. Classical example of Himalayas itself I can take it because zone 5 in Himalayas, zone 5 in India is located along what? Himalayan stretch. I can talk about Chilean earthquake, right? I can talk about again Pacific Ring of Fire. I can say that, say for example, nearly 90% of large earthquakes are confined to what? Pacific Ring of Fire. Then they also ask about the association between what? Fold mountains and volcanoes. Somewhere I can say that along the subduction zones, right? Wherever I have fold mountain, that is the same place where I'll be having volcano, but we have one exception. What is that exception? Himalayas is going to be that exception. So what you can do, my dear friends, all these answers to the question, somewhere you can write. Maybe write it, you keep it whenever time permits. Somewhere I can give my comment. Kindly do not submit it. Right? Write it and keep it, at least for your mental satisfaction. Okay. So formally, I am just completing this plate tectonic theory. The rest we'll see it in the next time. Thank you.